In this lesson we'll talk about two more transformations, the dilations and reflections. And if you pause the video and copy this, then we can talk about it. So a reflection will multiply by a negative. If we add or subtract, that's going to be a translation. And then if we multiply by some other number, that's a dilation. Then horizontal transformations are inside with the x, so that this negative is horizontal because it's inside. Here this minus a is a horizontal transformation, and here multiplying by a inside the parentheses with the x is a horizontal transformation. And then if it's outside, that'll be a vertical transformation. When we have a horizontal transformation, we have to do the inverse of whatever is done here. So just to keep the rule the same all the time, we can just say divide x by -1. Over here, we'll say multiply y by -1. And here we have, we have to do the inverse of this, so we're going to add a to x, and here we're going to not do the inverse, subtract a from y. Here it's inside, it's horizontal, and we do the inverse. So we're going to divide x by a, and here we have multiply y by a. And then we'll make sure that we do the multiplication and division before the addition and subtraction. And we can use the same table that we used in the previous lesson. Okay, so we this one's not too hard to see, but we want to make sure we rewrite it as if this is f of x, if we write it in function notation, now we're going to say f of x is x squared, and then we can say that the transformation g of x is going to be 1/2 of f of x. So then we can really see whether this 1/2 is outside or inside with the x. Since it's outside, we know it's a vertical transformation, and we're going to multiply all the y values by 1/2. So if we put f of x, which is the parent function, there shouldn't be an equal sign there, and we're going to go -4, 2, just the points in the parent function. And then g of x, we just multiply all the y values by 1/2. We don't change the x value. Multiplied by 1/2. Multiplied by 1/2. Parent function, and then we'll plot these points, and that is over 2, up 2, over 1, up 1/2. Here we have the 1/2 and the 2, and we can see that that is a vertical compression. It's a dilation. We're multiplying by some number, and it either stretches or compresses the graph. Okay. Pause the video and try that one. So if we say the parent function is f, then g is going to be 3 times f, and multiply the y values by 3, because 3 is outside, it's a vertical change, and we're multiplying all the y values by 3, so we'll have a 12, 3, 0, 3, 12. Parent function, and then we're going to go up 12 here, -1 up 3, 0, 0, 3, and 12. Alright, and that is a vertical stretch. Alright, let's graph these. And if we identify the parent function as x squared, then we can look at whether this 0.25 would be inside and the negative is outside. So if we say the transformation is a negative on the outside of f with 0.25x on the inside, now we can see that the 0.25 is inside or horizontal and the -1 is outside or vertical. Remember, for an inside change, we're going to do the inverse of this operation. This says 0.25 times something, so also remember that's 1/4 times x, and if we were going to divide by 1/4, we're really going to multiply by 4. So if I have f of x for the parent function, and g of x, we have we're changing the y value with this and the x value with that, so we can do it all in one row. Let's go ahead and multiply the x values by 4. And then we want to multiply the y values by -1. And parent function will be like this. Then we'll go -8, -4, +8, -4, -4, -1. and we would say that that is a vertical reflection, also called a reflection in the x-axis, and we have a horizontal stretch. We could say vertical compression, but since it's inside, and we see that it's inside, and we change this by changing the x values, so we'll call it a horizontal stretch, and it's stretching it out sideways. Pause the video and try the next one. So if we say the parent function is x squared, then g of x, the transformation, is going to be f of 2x. So now we see the 2 is inside, it's horizontal, and we will divide. We have to do the inverse of multiplication. We're going to divide the x values by 2. So we have f of x and g of x. And we're going to divide the x values by 2. And the parent function is here. Now we're going to graph over 1 up 4, over a half of 1. And there we see a horizontal compression. Okay, so now we have a translation and a dilation. Let's identify the parent function, and then we'll write g of x in function notation in terms of f. 3 and 4 are on the outside, so we have 3 times f of x minus 4. So that shows that the transformations are vertical. And we'll look at the coordinates for the parent function. Alright, we are changing the y value with both of these, so we should probably do it in 2 rows. Make sure you do the multiplication first, so we'll go 3f of x. Multiply all the y values by 3. So now we get 6, 3, 0, 3. Ooh, that's supposed to be a 2. Glad I caught that. And multiplied by 3 is 6. Alright, we're not going to change the x value, so I'll just leave it. And now we have 3 f of x minus 4. and we're going to subtract 4 from all of the y values, and we'll just keep the same x value because it didn't get changed. Parent function, I'm going to plot these points, and we'll see the transformation, -2, 2, -1, -1, 0, -4, 2, 2, so we see a vertical translation and a vertical stretch. And I just want you to realize that the problem would probably be written like this. And if it were written like that, then we'd see that's a horizontal change. Let's say that's vertical. Well, I'll leave that up to you. Pause the video and try that one with keeping this in mind, that the parent function is 1 over x. And then we have to look at what are these numbers doing to this parent function. So pause the video and try that. And we would have g of x is going to be 1/2 times 1 over x, 1/2 f of x, and then plus 2 is on the outside. So we have 2 vertical transformations, and the parent function we just want to use from this graph. We have that point and that point, -1, -1, and here's 1, 1. Then we just have to multiply the y value by 1/2. So we'll go 1/2 times f of x. Multiply the y value by 1/2. Then we're going to add 2 to the y value. So we have -1/2 plus 2, and we'll get 1.5. +1/2 plus 2, and we get 2.5. Parent function. And now we have -1 up 1.5, -1 up 1.5, +1 up 2.5, and we have the vertical shift of 2, so that means the horizontal asymptote moved up from here, moved up 2, and we still have the same vertical asymptote. We do have a this 1/2 is making everything lower, so that's going to give us a vertical compression. So here we have a vertical translation and a vertical compression. Alright, so if we say that the parent function is the greatest integer function, also remember that the points that we can use from the parent function are just these points. Those are the ones that we're going to use, but then remember the graph goes like that. Okay, the other thing we have to remember, this is not a, we wouldn't read this as a horizontal shift to the left of 4. We have to have this factored before we can do that. So let's say that g of x is two x plus 2. So we take this has to come out of both of them. We're going to factor out a 2, and that's what it looks like. That's all on the inside, so we could say that g of x is f of 2x plus 2. And now we can identify that these are both horizontal changes. We're going to do the inverse of multiplication and the inverse of addition to the x values. So let's look at the parent function. Negative 2, negative 2. I'm using this negative 2, negative 2, negative 1, negative 1, 0, 0, 1, 1, 2, 2. And we need to do the multiplication or addition first. So let's do f of 2x. And we have to divide the x values by 2. Okay, and then we'll do f of 2x plus 2. And now we subtract 2 from the x value. So minus 2, minus 2, minus 2, negative 1.5 minus 2 is negative 1. We didn't change the y values. And we have a negative 3, negative 2, negative 2.5, negative 1, negative 2, 0, negative 1.5, positive 1, negative 1, 2. And remember that those are the left endpoints. And then right below we have open circles, open circle, and that was a horizontal translation and a horizontal dilation. This is a horizontal compression because we divided by 2. Okay, pause the video and try this one. The parent function is radical x. We want to write it as 1/2 x minus 2, because if I distribute the 1/2 it would take it back to a 1, so this is how we factor it. It has to be factored for us to see the horizontal transformations. And remember that we need these 3 points, 4, 2, 1, 1, 0, 0. And this would be g of x is f of 1/2 x minus 2 So f of x, parent function is 0, 0, 1, 1, 4, 2. We have to divide by 1/2. So we'll have f of 1/2 x. Divide by 1/2 means multiply by 2, multiply the x value by 2. Then this we're going to add 2 to the x value, 1/2 x minus 2. Add 2 to the x value, and then we'll have over 2 up 0, 0.34, 4 up 1, 5, 6, 7, 8, 9, 10 up 2. And that will be a horizontal stretch and a horizontal translation. And let's just do one more example, and it's graphing a piecewise function. Alright, so to graph this, we have 3 different regions with 3 different graphs, but we'll just put them all together. So if we want to be very careful with this, we could just graph 3 separate graphs with the strategies that we've been using, and then put them all onto the same graph. So we know that horizontal line at 3, and we want it between -2 and 7. We'll have a closed circle at -2 because of the equality, and an open circle at 7. Here we have the parent function and the reflection. Multiply all the y values by -1, and we want to keep that only to the left of -2. -2, -4. We want to have an open circle and then draw it down like that. So we don't want any of this. We're only going to use the part to the left of -2 because this says to the left of -2. Then we have this graph. We have the parent function, and this is going to go right 5 up 2. And this is to the right of 7, so 5, 6, 7. And this will be, this up to, this will be a closed circle at 7, 6. We don't want any of this. And now we can just put them on the same graph. And if you're confident with it, you can just do it all in one graph to start with. So we have a closed circle at 7, 6. Then 3, we have an open circle at 7. It goes back to -2, and that'll be a closed circle. Then at -2 will go down 4, and that's an open circle. The parabola. And here we have the parabola also. Alright, and we'll stop there.